Hello students, you are welcome to the continuation of your week 10's tutorial still on integration application. We shall now be looking at tutorial 3, the present and future values on the accumulated funds. Let's look at an example. In present value, you are looking at the value of an investment now if you want to make so much in the future. And the future value means what will be the amount of an investment that you put in now over some period of time. In the case of the present and the future values, we only make one deposit and then we can determine how much that deposit will make as additional investment in future, how much that investment will make at a particular rate. Let's see this question. Let's start with the future value. Find the future value P of each amount P0, investment for time period T at interest rate K, compounding continuously. Now we have been given P0. This P0 stands for our present value. T there is the number of years, 6 years, and K is the interest rate. So now we need to know the formula. That's the formula for the future value of an investment, compounded continuously. In this case, our future value is P of T is equals to P0, which is our present value, times e to the power of kt. So it means we just substitute the values. P0 will be our present value, 100,000. E is constant as our exponential to the power of 0.03 because it is 3% in decimal. And then times your t, which is 6. If you input that into your calculator, you're going to be having that. So it means into 2 decimal places, it will be 119,721 rand 74 cents. That is our future value. It means if you put in 100,000 now at that rate of interest for 6 years time, it's going to earn you that. So the difference there will be about 19,721 plus 74. Let's go to example 2. Let's see how to determine the present value. Here we're told to find the present value P0 of each amount P investment for the time period at interest rate K, compounded continuously. So our P there is 100,000. It means if I want to make 100,000 in 6 years time at the rate of 3%, how much should I put in now? That is my present value. So P0 still remains our present value. Now we need to do a little bit of manipulation here. This was the formula that we used before. Now to determine my P0 here, I divide both sides by e to the power of kt. So in essence, P0, which is my present value, is P of T, which is my future value, divided by e to the power of kt. I could rewrite this by bringing this up and it becomes a negative power. So now, to determine my present value, my P, which is my future value, is 100,000, divided by e to the power of 0.03, which is my K there, and my T, which is 6. You put that in your calculator, you're going to be having 83,527 rand 0.02. That approximately that. That is your present value. So it means if you put in so much over 6 years, you're going to be making 100,000 at the rate of 3%. Let's now look at the one that has to do with accumulated funds, which means accumulated funds or deposit means you continuously put a particular amount of money over some period of time, and then you want to see how much it will earn you either in future, or rather, if you want to find the accumulated present value, it means how much will you have to be putting in now to make so much in future. Let's see this example. It says to determine the present value of a continuous income at a constant rate of 1,750 for 10 years. Use the future value of the continuous money flow, which is true. Now this question is talking about us finding how much will have to be putting in regularly to make so much of this in 10 years. So it means in 10 years time, 10750 times 10 is about 17,500. That's my accumulated money I will make. Well, how much will I be putting in now to make so much in 10 years? So I need to first of all multiply this by that, which gives me 17,500. So it means I want to make 17,500 in 10 years time. How much will I be putting in on a yearly basis to make so much? That is my accumulated present value. And so we're going to be using that formula there. it's r of t e to the power of kt dt. Assuming that I know my a now, my a is 17,500. So I'm looking for my p0 there. My p0 there is my present value that I need to be put in on a continuous basis. And so let's impute that 0 to 10. 10 there is my number of years. P0, which is there. Now, don't confuse the two. The P0 is still standing for your RT, so it's the same thing. And e to the power of 0.095, because it is the question is not stipulated, but it is at 9.5%. Now, so it means that is that, and then don't forget how to integrate your exponential. You differentiate the power, it gives you 0.095, you divide by 0.095. Okay, and then after that you substitute for 10 for t. Okay, and you divide 1 by 1, 0.095, it gives you 10.5. And then after that you put 0. If I put 0, I'm going to be having that. And then I subtract the 2, I'm going to have that. Now at this junction here, to find your present value that you're going to be putting every time, to make so much, you divide 17,500 by that 16.64, and that gives you that. So it means I need to be putting in 1,051 rand 37 cents every year to be able to make 17,500 in 10 years time. That is the accumulated present value. Let's look at the accumulated future value, for example 3. Here we're given the future value of a continuous money flow of that much. And this is given in function in terms of t, rands per year for 7 years. So it means my t is 7 years, that's my accumulated profit, that's my k. We are told to find the future value, so it means I'm looking for the value that will give me that. Okay, and so that is the formula. This is the future value there. Let's find the present value that will give us so much. Sorry, this is still on present value, so it means that is my future. And we just need to substitute for t as 7, and then equals to that. I've already integrated that because my years is 8 years. This will differentiate that, it gives you 0.08, and that's it there. And then you substitute for t as 7, that's it there. You substitute for t again as 0, that's it there. Subtract the 2, and then you have 9.38. Divide both sides by that, you have your p0 as 2,108.74. That's how much you need to be putting in as a present value to earn so much. Now let's go to more examples. In example 4, it says at age 35, Rochelle earns an MBA and accepts a position as vice president of an asphalt company. Assume that she will retire at the age of 65, having received an annual salary of 95,000, and that the interest rate is 6% compounded continuously. What is the accumulated present value of her position, and what is the accumulated future value of her position? So here we're going to be looking at the present value, accumulated fund, and the accumulated future value. Let's go to the first question. Here we're still going to be using that formula, which is the formula for our accumulated value, for the accumulated present value. And so here, first of all, let's determine the time. The time will be between the difference in the age of the retirement and the age that she started the company. If you look at it there, the age that she started the company is at 35 years. So it will be 65 minus 35. And that gives us 30 years. So T will be 30, that's it there. Your interest rate is 6%, which is 0.06. And your R of T, which is the investment of that annual salary, which you should be depositing every month, is every year is 95,000. Now, let's see. So it means I'm using that formula there. My R of T will be 95,000. I will take it out of the integral sign. My T will be 30, from 0 to 30. E to the power of negative 0.06 as my K. Still leave the T there. Don't substitute it yet, because you have to first of all integrate, and then after you substitute for T. So if I integrate that, don't forget the way to do that. You differentiate that, you divide by that. If I do that here, I've already omitted the step. If I divide by negative 0.06 and I divide it by that, it's going to give me this. So now after that, I substitute for T as 30 and T as 0. So if I do that, I have this. If I do this, I have that. Subtract the 2 with your calculator, multiply that. It's going to give you this. The negative will cancel out. So this means this is the accumulated present value of the investment. Let's look at the accumulated future value of the investment. Now you see here, instead of me using a negative power, I'm using a positive power. That's the difference between the accumulated present value and the accumulated future value. The future value has a positive exponent. Still using all the same values as before. You can see the only difference is that the power has changed to positive. And so I still take my 95,000 out. I will integrate that by differentiating the exponent and dividing by that, as we know. This gives me that. And then if I divide 95,000 by that, it gives me this. And then I put my t as 30 and then subtract, put the t at 0. If you do that with your calculator and you multiply by that, you have 7,995,275.14. That is the accumulated future value. That explains the difference between accumulated present value and the accumulated future value. Thank you very much, students. I'm wishing you all the best in your exams.